Sure.
I welcome on
So,
behalf of Professor Ramkrishna More College for this second session. Sir, please continue the session on SPSS. Thank you.
yeah, welcome to sessions. Good afternoon to everyone. So, in the first session, I discussed about that one-way table and two-way table, and reiterate that the measures, then analysis of covariance, partial correlations, and correlations. So, here is the one problem is that one. First of all, I want to share my screen. So this problem I'm going to my screen is visible for
No, sir.
my screen is visible.
No, sir.
Yes, sir. Now it's visible.
Now it's visible.
So this is the one visible. Okay. So just I'm tell the story of this problems. There are 30 are there in the class. Okay. So randomly assigned methods for 10 students. Three methods are there, 2 and 3. Assigned 10 students for one method. Okay. This is method 1, 10 student, method 2, 10 student, method 3, 10 students. What is the method is there? Here method is what? Suppose I'm not clear about that. In the first method, the student was instructed to repeat the word silently when it was presented. Okay. Second one is student was instructed to spell the word backward and visualize the backward and pronounce it silently. In the third method associated word with a strong memory. Okay, so these are the three students methods are there regarding the memory testing. Okay, and this is the score. Now I want to apply here table. First, how to in a data file. So look here. This is this is a method one. I'm taking one method one 10. The same thing I want to continue 11 method 20 21 onwards. I'm enter method 3. All these the 1481. So the first column is serial number 1 to 30, and the second column is method, and the third one is a recall. Okay, recall. Okay, the recall means numbers. So how to enter that I want to show you. Okay. So first of all, I define the variable. The variable is the serial number. Okay. So you may call it as a participant, no problem. Method 3, add. Okay. So now I want to enter 30. Okay. So here is a method is I'm going to use one. Okay. In a recall in a recall system, I want to enter these numbers. These numbers. So these numbers 1200431033. Okay. Here is the 1, 2, 0, 4, 3, 1, 0, 3, sorry, 3, 3. Up to this point is clear. I want to continue for this one. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So in this case, I am taking method 2. Okay. What are the numbers of that? Second number is 4, 4, 0, 6, 6, 6, 6, 6, 4, 4. Now, next 10 numbers 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Here method is 3. Okay. What are the numbers? 7, 4, 9, 8, 6, 9, 6, 4, 5, 6. Is it clear? All of you done
Yes.
it? Yeah. Now I want to apply one-way table. So the first you go to analyze, thereafter compare means, thereafter go for one-way NO. See that. Analyze, compare mean, one-way table. So you are going to get this dialog box. So what is your dependent from the list? Dependent. Anybody?
Recalls.
Very good. Correct, madam. Correct. Recall is a dependent. Now next go for the factor. What is a factor here?
Methods.
Method. Okay. Yes. This is clear or no? Now,
Yes.
after the analysis, I want to see the result. Post hoc. In this post hoc, these are the methods are there. Evaluation of variance. Evaluation of variance. Okay. I am going to select this one. Okay. It is a method. Okay. So significance level is 0.05. Now continue. Now see the result. So this is the recall. Okay. Between groups, and within groups. F ratio is there, test of variance 0.000. It is less than 0.05. That hypothesis is rejected. Suppose now post hoc test. In this case, we are going to check it method, method 2 and method 3, method method 1 and 2 0.003, method 1 and 3 0.000. This is rejected. Now method 2 and 1 0.003, method 2 and 3 0.03, method 3 0.003. So here is so here is comes a homogeneous subset. Okay, homogeneous subset means what here? Please note down this point. It is not strictly necessary that the sample size be equal in one way, ANOVA. When they are unequal, Tukey HSD procedure uses harmonic mean of the sample size for post hoc comparison. So here is the sample size is equal. So this Tukey HSD the uses harmonic mean sample size is 10. What happens here is between the square, squared, sum of squares, square. This is 0.00 is less than 0.05. So our hypothesis is rejected on the basis of this. Okay. No, this is different. This is different. Yeah. That 29 minus 0.0. This one. The rejected. Here is also that what happened 0.003 is also not significant. The 0.00 and this also less than that. And this also same situation is that this is also same. So there is a significant difference between the methods. So suppose if you see that mean subtotal see that the mean difference is also much is that minus 2.90 from method 1 and 3 is also minus 4.7. Significant difference is there. So that is why showing that one. hypothesis is rejected. Okay. So in the three methods are not. There is a significant difference is there in the method 1, 2, 3. Are you agree this point or not? Because regarding the this memory testing is that sometimes you read it and recall it that word, read the words and put in reverse way and memorize that word afterwards. So method is like that. So in method 1, 2, 3, there is a significant difference is there. That itself is showing in the result. Everywhere is showing that one. This is also significant result is a 0.0070. It is also less than 0.05. And if you come to methods also, here is also 0.003 less than 0.00 0.05. This also 0.05. This is this one. So there is a significant different methods. Anything, or do you want to take one more example? On the time?
Yes, sir. Yes, sir.
New. So here is the one problem is that compare the cholesterol of four competing diet foods on the basis of the following data. So diet food, four types A, B, C, D, and of that contains. So I have to apply the taken the 3 ounces of we want to test whether the differences among the sample mean can be attributed to chance at the 0.05 level of significance. The two things are there. I create serial number. Next one is I want to put it CC cholesterol content. Okay, this also numeric. Okay, this is a scale. And I'm using DF. DF means diet food. Food. I want to define the values. One D R E D. Diet A diet A, add 2, diet 3, diet 3, 4, it about that is the mu of B A of equal to mu C equal to mu of. There are three, there are four diets are there, and their cholesterol level. So it comes 3, 12 numbers are there. 8. Cholesterol contains is in the fraction, or I want to define decimal point, the 3.60, the 4.1, the 4.0, 3.1. Okay. So here 1, 1. The next one is a 2, 2, 2. Next is diet 3, 3, 3. Next 4. So 4 into 3 is a 12 diets. So the first one is 3.10, 3.2, 3.9, 3.2, 3.5, 3.5, 3.5, and it's 3.5. 11 is a 3.8. So this is the data file. Okay, means cholesterol contains. DF means diet food, which takes the values. Diet food A, food B, food C, food D. So I want to apply one-way table, one-way analysis variance, analyze, compare means, one way. Okay. What is your dependent list? Anybody? Dependent list.
CC will be dependent.
Yeah. The cholesterol contains
Yes.
the based on that food is there, right? A, B, C, D. So this is my dependent list, and this is my factor. Okay. So post hoc test is there. I want to select Turkey. Don't go for any other things. Significance level is a zero point zero 0.05 and continue. Okay. Yes. So here CC is comes. Okay. Suppose if you are confusion, you can do like this also. You can write the full name of that variable you label it. Okay. Cholesterol. Cholesterol con- content. Okay. See that any changes in okay. Let us. I want to check it once again. Got it, man? Cholesterol content. In variable is a CSI label combined. So the system is showing that this one. So it is very easy for understanding. This also I have done it same thing. Continue. See that. Now we got complete. Cholesterol content. What happens here? Sometimes 8, sometimes 2, 3. I think the mistakes here somewhere. Hmm. Here, okay. This to remove it. B. This E. This is D. So after making the changes, we first click on that change. Then only accept. Otherwise, no. So please note this point. See. Sorry. Go one way, reset it, cholesterol dependent list. This is factor. You can go for this. Okay, continue. And options, whatever things are available. Descriptive can go for that. Okay, homogeneity of variant test also you can check it. Okay, see that. So see that in a dialog box, if pressing the one box, there here. Descriptive. If you see that diet A, B, C, D, the mean value is 3.9, 3.4, 3.4, 3.7. Okay. So here, if you see that the cholesterol based on the mean, based on the median, based on that, everywhere is a significant. That is a point greater than that, except the null hypothesis. Okay. So now come to the ANOVA table. See, between the groups, within the groups, yes, it is a 1.16 is greater than 0.05. Null hypothesis. Here, if you this test, see diet A, B, diet A, C, diet A, D, all are greater than 0.05, except hypothesis. Okay. Similarly for this, remember this. So here that is clear, the mean is almost always equal. Either you can take the diet A, diet B, diet T. No anything on the by eating the diet A, cholesterol level increases. Not like that. If it increases cholesterol level by consuming diet A, diet B is also increasing cholesterol contains by diet C also increasing, and also D. The difference between the diet A, B, A. So you see that here is also multi comparison also. Diet A along with diet B also significant. Diet A and C also significant. A and C also except the hypothesis. Similarly for diet B A 0.23 except the null hypothesis. See that the result itself is not showing that. But in the previous example was different. That hypothesis was rejected. Any questions on this part? Any question?
Any doubts, scholars, please ask.
No, sir. No.
No, sir. No, sir. There are no doubts.
Okay. I want to use repeated measure NO table. So what I told, repeated measures of NO table. So here is observe the things before, observe after sometimes, and after sometimes. So time factor is a T1, T2, T3, T4. Suppose if employee joined any organizations at the time of joining level, after the training, their performance level, after 6 months performance level. If you want to test these things, you must use the repeated measures of ANOVA table. This is also most important. I'm taking one example. So, so there are 10 students are okay. The performance beginning of the term after 6 months, okay, after 1 year. The three parts are there. So I want to create. So instead of variable name, just simply I can go for serial segment number. If you want, you can take it. So this is numeric is there, and before numeric decimal point. Okay, this also not decimal. Okay, this is scale after DFT after numeric decimal scale is there. Then this month. what happens? Anyone is going to no. The space is in variable names. Which is the variable. We come to the data. I want to enter before 13 8 20 19 10 10 8 1 values 13 8 12 20. Okay. After 12 15 16. After 6 months 7 4 16 2 15 13 9. Okay, this is the coding system. I want to apply repeated measures of. Okay, see that analyze, you select generalize linear model, general linear model. Okay, the one more is a generalized linear model. It is a different. We select the general linear model. In that one, repeated measures. Okay, so number of levels you can select 3. Okay, and what is the factor? So all these things are related to the time factor. I, yes, before after 6 months. Okay, add it 3 level time frame. Define the first one is before, Okay, before 1, before 2, before 3, after 6 months. I'm not going to tell other things. See, go for option. Descriptive. Continue. Then see the plot. The time is there. It's okay. Time 1 to 3. Independent variable before after 6 months. Before is 11.05, 14.60, 6 months is 13.0. So there is missing values. Just 1 minute. Analyze general linear model, repeated measures, 3. You can go for the reset. You remove type. Factor 1 is not. If the factors are there, it will input. Simply you can go for time. Number of level is a 3. Add it. Okay. Define. Define before, after this. Covert is not. I'm not going to. Sorry. Okay. Before, after, this is now option. So I go for this descriptive statistics and estimate the effect size. This also I want to select it. Okay, that is why my result is something shown to print. Any other things? Compare. Display means more is not. This also you can check it. Continue. Plot It's okay. Okay. So I'm not getting a expected. Okay. Just 1 minute. So in my SPSS software, I'm able to get a one more window is that regarding this matter. So that is why I'm not getting the answer of this. The effect is getting that. This is not expected report. So this is a procedure of someone is the higher version of SPSS, you may get it report. Okay, the report. The same thing is that the time 192, 193, 2 and 1, 2 and 3, 3, 1, 3, 2. So the significant value may be greater than 0.05 if it is accept the hypothesis, otherwise reject the hypothesis. So I'm not getting expected result of all three because what happens is it is very difficult to understand. So if you see that mean is there 11.70, 14.60 and 13.60. So that mean is almost all the equal. Okay. That is significant. Significant. There is no any difference. No significant difference here. Okay. The before and after 6 months training. But rest of tables are not as per my requirement. Okay. If it is possible, tomorrow once again I want to take a different example and see that one related to this one. Means of anode table. Okay. My software is not supporting to this. So I think it's correct. Now I told about analysis of covariance and COA. Okay. So one nominal effect of one nominal independent variables on a continuous independent variable controlling effect of another continuous variables. So here is we are going to consider controlling called as covariate or compounding. So on that basis, I'm going to solve one example on this. So already I created this data table. ECNOA and COA. Okay, Excel sheet. So these are the method one, method two, method three. Okay, so the teaching method one. This is the teaching method. This is the student marks. The teaching method two. These are the marks. Teaching method three. These are the marks. So this is a family income controlling part. So this is a controlling part. The method is a nominal. Is also scale. Okay. Dependent variable on a continuous dependent variable. So here is the nominal independent variable teaching methods. Teaching method 1, 2, 3 and continuous dependent variable is result or marks. Suppose if you want to say that you can change it. Okay. Result result. Okay. Or you keep as it is. Marks. Here you can change it. label results okay. Now one more is there, method is there. I want to define method 1 method 1 add 2 method 2 add 3 method 3 add. See that data view how it looks. You can change it. One, 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 two, 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 three. Okay. This is the suppose if we change, if you want to see that, you can see 18s are there. From this hypothesis, there is no significant difference in the effectiveness of three teaching methods after controlling family income. So analyze general linear model. So here is we go for univariate. Univariate. What is our dependent variable? Dependent variable result. Okay. The fixed factor is and the family is comes covariant. Controlling factor. That is family income. That we have to consider it. Then option we go for descriptive homogeneous test. Yes. For this also I'm not getting a one more window. See that. So the sample size of each method is a 666. Okay. Univariate analysis. In the method 1, method 2, method 3, the mean is 43.67, 54.33, 57.83 is there. Okay. the method 1 little bit less as compared to 2 and 3. Okay, so now here is variance is that equality of the variance. So significant value is a 0.065, which is greater than 0.05. So it is a accept the null hypothesis. Variance are equal. Okay. So we come to here. Is methods is there. Methods. What is indicate methods? Hypothesis is this is a significant. It is a less than 0.05. Reject the hypothesis. Reject the hypothesis because this method is see method 1 is a 43.67. Actually I want one more result between the I'm not getting this here. There is a significant difference between the methods. I can say this much is only for this example. Earlier, what you defined, there is no significant difference in the effectiveness of three teaching methods. Okay. So by saying this one methods, it is not a this value is less than 0.05. Okay. Reject the hypothesis. That means there is a significant difference in the effectiveness of the teaching methods. So supporting to this statement, if you see that this one is a 0.67, this is a 54, and this is a 57. Okay, these two mates are okay. This is not right. So if you are using the higher version SPSS, I am using the 24. Even though I am not getting a one more window is the display. Yes, anybody's? Any questions?
Scholars, if you have doubts, please ask.
Yes.
Anybody has doubt?
No, sir.
The practice is required. Sometimes the pirated softwares are not supporting every times. I am also facing the problem of this particularly. These things are there. Analyze general linear models. Linearity is also not read properly, and repeated measures is there. Okay, procedure is the same. You can check it. Okay, so I can't say anything much. So here is a one example related correlation is that I explained about correlations. Okay, One question is that one. There are 5% about the satisfaction with the various aspects of dormitory. Noise is one factor. Furniture is there. Space, study, okay, safety, and privacy. So these are answered on 5-point Likert scale. So everyone knows that one. What's the meaning of Likert type scale? That means you can say that very dissatisfied to very satisfied, 0, 1 to -1 and -2. Okay, very dissatisfied, neutral, satisfied, very satisfied. If things are like that, out of 5 they are giving some marks. So these kind of things are considered as what Likert type scale is there. So in my example of correlations, I used this point. So how all these are related to each other. So So this is a question that is related to the students' level of satisfactions in college. The first point is noise, second is the furniture, study area, safety, and privacy is there. Okay, how these three things are related to the thing. So here is assume we also assess the student family income level. So here is hypothesis that to test the hypothesis that satisfaction with the college living environment is related to family income. Here, this survey is the some good colleges, rich management, always giving good services, good facilities, good infrastructure to the student to study. But these things are not happening in the other type of colleges. That because of so many reasons are there. Okay, the fund is not available, management is not ready to spend money for infrastructure and all these things. So we want to check how, sorry, student satisfaction related to these things. So how they are going to adjust with the noise, furniture, study areas, safety and privacy in respect of the income. So this I want to create this one. All are just I want to take one more example. Okay. So the 10 students are accept consider. So a number. Next income. So income is a numeric. I don't want to protect this one. This also measures is all of the scale. Noise. Okay. Noise is also numeric values. Sorry, not nice. Then NOISC. Okay. This is also integer. Okay. Because all of the Likert scale is there. Furniture, Next is study area. Safety. Then last is the privacy. Suppose if you see that data that there, I don't want to variable is every time I'm committing the mistakes. 4, 5, 7, 8. So income is something about 39, 75, 90, 67, 58, 40, 55. Then I see 5, 3, 4, 5, 3, 4, 2, because it is a Likert scale is there, 5 pointer, 5, 2, 2, 2, study area, 4, 5, 2, 4, 2, 2, 1, 4, 5, 1, 5, 15, 5, 2, 1, 1, 3, 4, 1, 4. Last one is a privacy, 5, 4, 2, 5, 2, 1, 4. Okay. So this is the data file basis. So from this, we are going to calculate and testing the correlation coefficient. So for that purpose, morning I told that analyze, then here is a correlate and go for bivariate. Analyze, correlate, bivariate. Okay. So what are the variables are there? All are the variables except student. Okay. In this way, you have to transfer it.
नंबर दिया बार फोन करो
Okay. So after that, correlation coefficient is there. Correlation coefficient, the
नव्याण्णव पंच्याहत्तर अठ्ठ्याऐंशी 63 53
हॅलो.
ओके ओके
हां, 1 मिनिट सर.
Pearson, Carl Pearson coefficient of correlation, Kendall's is there, and Spearman correlation coefficient. The Carl Pearson coefficient is applicable for that
महाराष्ट्र बंद म्हणतोय
quantitative variables, and Spearman is comes the qualitative.
हा
So
हा
I'm going to use it Pearson correlation coefficient. Okay. Okay. See that this is a correlation coefficient. Just I didn't use 1 minute. Again, I want to use calculated by delete. All these things are okay. In options, you can go for mean and standard deviations. Okay, continue. Then yes. So I got descriptive statistics. So because of one option is not selected, therefore I didn't get it. The sample size is correct. 10, 10, 10 is there for each. The income is 73.80, 2.90, 2.0 of this. Our objective is what? Our objective is to test the hypothesis that the satisfaction of the college living environment related to the family income. How all these things are related to that. If you see that correlation, so this is the one value is the diagonal part 1, 1, 1, 1. Please observe it. Observe it. Okay. The whatever value is above this line, the same thing is repeated over here. Yes or no? Observe it or no? Correct? Yes or no? 800, 800, 702, 710. So, the SPSS lacks significant correlation with asterisks. So, whatever the things are there, here are the correlation coefficients. Significant correlation with the coefficient. The strong, all are zero point 0.8, zero point 0.7, zero point 0.8, like that. Okay. All are the significant correlation values. The correlation matrix is a symmetrical. It is symmetrical. So the above the diagonal entries are the same as the below the diagonal entries. So the strong negative correlation between the family income, then we see that if you consider the family income, negative correlation is there. and a strong positive correlation among the other items. Yes or no? So this is a observation from this one. Family income as well as these kind of other items of negative correlations. Any other? But tomorrow I am going to cover it non-parametric test. Okay. Any other questions?
Scholars, if you have doubt, please ask.
It's okay, no problem for that. I want to wind up today's sessions. So thank you very much. Okay, madam.
Okay, sir.
Yeah,
We will meet on tomorrow, 2
tomorrow.
p.m.
Okay, 2 p.m. I'm going to cover non-parametric test.
Okay,
Very easy for you. Okay, not that
okay,
much
sir.
of complicated like this.